All right, well, if everyone's topped up in brownies and lemon tea, we'll start off with our second session. It's my pleasure to introduce Dominik Weissboeck. Dominik's got many years as a developer, software architect, and Dominik's now GM for Tricentric Asia Pacific. And he's presenting today on model-based test automation. Dominik?
Thank you, Tim. Well, thanks for the opportunity. Thanks for your time being here. Before I start, could I have a show of hands who has test automation experience? Okay, at least 10%. I guess it's even more. All right, before I talk about the concept of model-based test automation and its benefits, I would like to tell you a story that I've heard last week at an event in Sydney, because the story is somehow related to the journey of model-based test automation. It is about solving a problem of quality and throughput. I don't know if any one of you have ever heard about Charles Kettering. Charles Kettering was the chief research engineer at General Motors in the 1920s. And he was a very passionate person to take General Motors to the very top. And in the 1920s, painting a car was a real stumbling block for the automotive industry, because it took very long. General Motors, in this case, it took them 37 days to paint a car. Now we have to understand, in the 1920s, painting a car was done by hand, brush stroke by brush stroke. Many coats, and it had to dry in between. Now, so Charles set out and challenged his engineering team, his painting team, and said, look, we've got to do better than this. So you go away, do some investigations, and you come back with your best effort. About a few weeks later, the engineering team came back, and they thought that they had a really good news for Charles Kettering, and said, look, we think we could do it within a month. And Charles was not very pleased. He said, in a rather snappy way, I would rather like to have it within an hour, not a month. And so they said, look, this is impossible, it's not going to happen. What happened then is that Charles was on a trip to New York, and in New York he walked on the 5th Avenue, and he passed the window of a jewelry shop. And in this jewelry shop there was a wooden pin tray that was painted with lacquer. And the lacquer looked very different from paint that they had used to paint cars. And so he thought, maybe there's something to it. To cut the story short, he bought that tray, and he tracked down the company who made these trays in a backyard shed in New Jersey. And what that company had invented was paint that you could spray, and that would dry within minutes. So he took that paint back to General Motors, and he invited the head of the paint team for lunch. And they talked about lunch, and after that he walked him to the parking lot of GM, and where the person, the head of paint, confessed that he could not find his car. And so Charles pointed at the vehicle and said, isn't that car yours? And the person said, well, it looks like my car, but my car is not lime green. Upon which he said, now it is. And so what he did is something that I believe should be, or is an ingredient to any success in any undertaking. Regardless if this is model-based testing, or if it's risk-based testing, or if it's whatever you do, I can strongly recommend these few ingredients. Always challenge your status quo. Never stop. Be curious and have an inquisitive mindset, like little children that never stop asking why. look outside your frame of reference. He would not have found that solution to painting cars quicker if he had just improved the painting by hand with his existing paint. And have a passion for sorting problems. Okay, so that's a story that I've heard last week, and I thought it's worthwhile passing on because it's truly 4 very important ingredients for any success. Now, the journey of model-based test automation is a similar one. It actually started in the early 2000s with a problem that Allianz had to solve. Allianz had, by and large, used Power Builder to build their systems back then. And they wanted to migrate away. They wanted to migrate to a newer technology, to reach out to the internet, obviously, to make systems more scalable, that they could develop them faster. And so they did their studies, and they had chosen for Java to replace their existing systems with a Java system. But the processes, how they ran, for example, their claims systems, how brokers went about that system when they were out selling insurances, didn't really change. It was by and large the same processes. So what they wanted to do, what the problem they had is they said, look, we are changing a technology, we are migrating to a new technology, but we are by and large having the same business processes. So when we do this technology migration from Power Builder to Java, what we want to make sure is that firstly, our old system, our Power Builder system, is the point of reference. It's the source of truth. We will test the new system against the old system with regard to outcome of business processes. Secondly, we don't want to reinvent the wheel and build the assets for each and every system. We want a solution that has real good capabilities for reuse. So if we build test assets with test logic for our existing system to run them against the Power Builder system, and we're not changing the business processes, we're only changing maybe the flow a little bit and some data that we feed into it, and maybe we twist and fine-tune them a little bit. We want to use these assets that we've developed in Power Builder across to the Java system. And I had a similar challenge last year actually with a government organization in Australia, one of the largest organizations there. It's ComSuper. They are responsible for superannuation for all civil servants and military services in Australia. And they have a similar problem. They are migrating a Gupta system to a .NET system. But the process is the same. How they manage the funds is not exactly the same. Just get some more modern interface. Now, we had to secure that we avoid rework with that migration, that we reuse these assets, that we can use the old system as the point of reference, but test the new system effectively. Now back then, this was early 2000s, we looked at what existed in the market. So what could we do with regard to automation? Because if we run these test cases here, we can almost use the output as the reference point for the verification put of the output of the new system, from the old system to the new system. Right? And what we looked at back then, what was available was record and replay approaches and test automation frameworks. Who is familiar with record and replay? Has ever used it? A few. Now for those who have never heard about it, record and replay is nothing else. There is a little program that sits on your computer and it records user behavior. So it records your keystrokes and your mouse clicks. And it generates a little program, code, and you can then execute the code. And all the code does, it clicks the same keystrokes and the same mouse clicks. Now when you looked at that problem that they had, you wanted to reuse test logic across the systems. That was not really an option, because when you do record and replay, you hardwire the test logic straight into your code. So your test logic disappears in the dark art of code and is buried in there. At best you have a label of that little keyword that tells you what it's supposed to do. but the detail is lost. Further, if you were to change the flow only slightly, or if you were to twist and tweak the data only slightly, these scripts would break because they are hardwired. All they do is they simulate the same keystrokes and the same mouse clicks. So record and replay was not an option for us. We could not use it. So we looked at, obviously, the next evolution, which evolutionary step, which were test automation frameworks. Who is familiar with test automation frameworks? Same people, right? Test automation frameworks is an evolutionary step. It is still a script-based solution, so it still uses some code, descriptive code or procedural coding. But the intent of test automation frameworks is that you build a framework that separates the test logic or your business logic that you drive with test logic from the underlying implementation for the automation. So you separate the specification from
Everybody's awake.
So the intention of test automation frameworks is then that you develop a layer that separates the specification from the implementation. Therefore, the specification is, let's say, independent, and you can twist and tweak it, right? And you can still run it against these systems. Now, you obviously need to develop a framework for the old system, to drive the old system or the power builder. You've got to have some connectors there to run that. And you need to develop that framework or extend it to the new system. Now, for those of you who have ever done framework development with descriptive programming, they would know you would use something like keywords. A keyword is a placeholder for a function that you need to execute. Could be something like you need to enter a client in a system. So you have a keyword, enter a client, and this enter a client obviously has some parameters that go into it. So there's a name, there's an address, there's a zip code, there's a country, whatever these parameters are. And within that keyword, the keyword would not give you more. So the keyword would just descriptively describe what's that function that it does. But the implementation of that keyword is very much like a function call. And for those of you who have programming experience, that's like a procedure in procedural programming. So it's a function call, and that function call then has a set of actions that it does. It establishes a start point for the system under test. It has some key clicks and mouse clicks for navigation. It has some entry fields where data is put into the system. It has some validation points, and it makes some assertions about the state of the system after execution, because it's got to leave that system in a known state for the next keyword to pick up or for the next test case to pick up. Okay? So these keywords are like function calls. That's one way of doing test automation frameworks. You can then expand on that. You can use data-driven frameworks where you then also take this data that go into this function call as parameter, and you place that somewhere in a data source, and you assign this function to the data source, and then you say, just loop over this data and run this function again and again and again with different sets. Okay. Now, for those of you who have experience with function calls already have some test logic in it, at least with regard to the system, the implementation. Because the mouse clicks and the keystrokes that you do for navigation between these entry fields are hard-coded in your function call. Someone codes them, right? So in that sense, the test cases are not necessarily entirely independent of your implementation, because there's some test logic within your test automation framework, not purely in your test cases anymore. Okay, so there's a bit of a spread, a bit of hardwiring in there. Unless you were to develop a test automation framework where each and every touch point of the system is an individual function. Right? Then you would get the kind of freedom again that you can really do what you want. You can change the sequence, you can change the data and everything. So in that sense, test automation frameworks solve a particular problem of the first generation, and that is the fragility. Because you can twist and tweak to a certain degree your test assets. But test automation frameworks are rather costly to develop. Because you need to develop them and you need to maintain them, and you do this by hand. It's like brushing the car, you know, brush stroke by brush stroke. You are coding these functions, function by function, and you maintain these functions. If anything changes, the test logic stays the same, you don't need to touch it, but if the system changes as to what these touch points were, you're back to coding. So in that sense, we thought it's still not ideal to the problem that Allianz was facing. Is there any other way? Is there anything else that we could do? And now obviously we could have looked more into, can we improve, for example, descriptive programming? Can we improve test automation framework coding? That would have given us probably some incremental improvements, but not necessarily solving the problem. So in that sense, as Charles said, I don't want problems improved, I want them solved. We didn't think it's really getting us where we want to. So what we did is we looked outside that frame and we said, we've got to come to a solution that delivers on the fragility, so it's robust, but that also addresses the cost factor and the scalability factor. Cost and scalability is cost of developing these frameworks and maintaining them. Scalability is because these guys, the guys of you who showed their hands, you don't find them readily in the market. They're fairly popular, and once you get them, you know, you hold on to them because these are the only guys who kind of develop these frameworks and maintain it for you. Now, I would assume that any one of you would agree with me, a really skilled programmer with endless resources can automate anything, okay? If I have endless time and budget and I have a really, really skilled programmer, you know what? I program you any automation on any system. But unfortunately, organizations don't have endless time and resources and money. So we've got to find a solution that's better, that addresses that, and organizations don't readily find that talent in the market. So they've got to live with what's there. Okay? So we had to solve the problem of skills, to reach out to non-technical staff, embrace them as well. We had to solve the cost problem, the scalability problem, and the maintenance trap downstream. So the idea was, we have, by and large, this was a systems environment as Allianz had it, or many other organizations, Suncorp, or probably here in Singapore it's no different. You have a heterogeneous environment where you have different systems. These systems use different technologies. There might be web services that you use as an integration layer. There might be message queues, such as TIPCO, where you have Java messaging services running, so that would be both non-UI interfaces. You might have HTML portals, you might talk to a database directly, you have Java applications, you have .NET applications, you have a Power Builder legacy application. You might exchange some XML files between two systems. You might have Swift messages or host a green screen. In order to get the kind of migration problem solved without redoing anything, we had to find a solution that gave Allianz not just a migration solution from Power Builder to Java, but one that gave them a migration solution from anything to anything. From UI to non-UI, from technology A to technology B, from packaged application to bespoke systems. And on top of that, the requirement was clearly set from them. They said, it's got to work across all these testing stages. It's got to work across component testing. It's got to work across systems testing. It's got to work for integration testing. It's got to work for UAT testing. And it's got to be in plain English. Because if that stuff is not in plain English, technical people, non-technical people can't maintain it. Okay? So we have to find a solution that is slightly different from what you can do with descriptive programming. And we didn't have to look that far. There are solutions that we already used with developers. Now, what we had to get is we had to get to a model for automation that is entirely decoupled from the test logic and agnostic to test logic. Okay? So you build that model. That model is nothing else but the interface catalog of these systems. Okay? There's no use to this model so far. They don't do anything. They don't have any, there's no function call programmed with some navigations and clicks. There's no starting point as such. There's no assertions for endpoints. There's no validation points in them. All these components of these modules, what they are a proxy of the interfaces of these systems. Now, I should have said the context here is black box functional testing. Okay, not white box testing. In white box testing, you go beyond, you look into what's behind these interfaces. You look into the implementation. It's a complementary discipline that I highly recommend to practice, absolutely. But the assumption here is we are a black box functional testing environment, so we don't have access to the code. We can use these systems only like human beings are using these systems through graphical user interfaces, or like other systems interact with these systems on non-UI interfaces or APIs. Okay? Now, then we would need to marry these up with our plain English test cases, whereby the reuse had to be warranted. If you scan a web service and the web service is used in an atomic component test for component testing, but we need the same web service in a systems integration testing where we do end-to-end testing as an example, and we stimulate even a system. We might mock a system for a particular purpose. We might actually send messages onto a message queue for the receiving system. We might listen on a message queue to messages from a sending system and read the payload, read the content, verify the message layer as such. Then we had to warrant that these modules are well encapsulated for what they do, no more, no less. Because the context for a component test of the same module might have very different data from the context in here in the systems integration test. The sequence on some actions that we take, graphical user interface, might be very different from a sequence of actions that we take in a UAT testing. Okay? So this model had to be entirely agnostic to the test logic. Vice versa, the test logic had to be entirely agnostic or independent of the automation model. Because if it wasn't, if there was some predetermined sequence, test logic, clicks, mouse clicks, or whatever you have, actions, if they were coded in function calls of your separation layer, I can't carry it across from one system to the other anymore. Because the other system might not flow. The business process logic might be the same, but the flow might not necessarily be precisely the same. So I would need to program them again. Right? And to avoid this, we looked at software development. Object orientation rather than descriptive programming. The principles of object orientation are separation of concerns, encapsulation, reuse, and polymorphism, in a nutshell. And what that does is you separate entirely the implementation from the specification. And there's no violation to this. You don't violate that principle at all costs. Okay. So what we had to do is we had to find a way where we could scan these interfaces, ideally even without any programming skills, so that non-technical TAs at Allianz could actually use that technology, scan the interface catalog, thereby they have the capabilities of this system sitting in the automation model, and they could now use these components very much like Lego blocks to build any scenario that they wanted. And the scenario could be as small as a component test or as big as a system integration test or end-to-end business process. So, another problem was then obviously how do we deal with maintenance? What if there's a change to a system? What if a field that used to be, or an action that used to be on screen 1 in the HTML portal now moved to screen 3? it had to follow the same principles, because otherwise it would not work. So the modules may only always encapsulate systems capability, but not the use thereof. And this might be a bit technical for some of you, but for those of you who know programming, in that sense, these components are like classes in object orientation. Like in Java or .NET or any other object-oriented development language, these are the static descriptions of your system, the classes, the definitions. These are not the runtime objects. The runtime objects are where? Anyone? Where's the runtime object? The use of the class. Okay? These two are entirely decoupled. There's no static link between a test scenario and the component. It is only at runtime, when you choose to execute a test case automatically, that information from here will be used to instantiate, in that sense, if you like, these components, use these components to act on the system. Okay, it's a completely dynamic process. There's no static links. In function calls, you always have still some static links in there, and some test logic is buried in there. And that was the idea. There's really, we didn't do anything revolutionary, really. We just looked outside the frame of what was common practice for test automation. We said, look, we've got to do something different, because obviously the script-based testing, the descriptive language in itself is an impediment to what we wanted to achieve. So we looked at concepts of object orientation. Now, in that sense, if anything changes on a technology aspect, on the interface, all you need to do is you synchronize the according module, and it's up to date, because these guys up there don't own the module. They only reference the module at runtime. Right? Big difference. The second, if you change anything up there, you're independent, because these are just the runtime instantiation of these. You can use part of these modules, you can use all of them, you can exhaust them, you can put them together and orchestrate them in end-to-end scenarios. And you can mix and mingle them across any technology. I could have a step where I start out on the HTML front-end, gathering some information, send this to the mainframe system, do some verification on the mainframe system, on the database, then send a message to the reserve bank via Swift protocol, because it's an international transaction, listening to the payload of the Swift message, and verify that it actually goes out the way I want it. So you can mix and mingle, that was another requirement, any technology, and also manual steps and automated steps. It doesn't make a difference anymore if you automate, if you execute a step manually or automatically. A test case in plain English describes only the intent of testing, not the concern of how you execute it. Okay? And that's the fundamental difference here. Now, in that sense, you decide in a model-based testing approach, and that was also a requirement from Allianz. They wanted to decide freely where the point and the sweet spot of automation is for each and every individual scenario. There might be scenarios where there actually is a manual step, such as scanning a fax, that then lands on a OCR recognition software that reads some information and puts that into the system. Right? You can't automate that hardware step where you actually have to place a fax that's coming in onto a scanner. So that was just then a requirement, you know. It's got to execute where we have steps that might run automatically, then it's got to prompt the user, say, it's your turn now, you do some actions, and then it continues automatically. And in any form, in any sequence, in any mix. Right? Now, what comes as a byproduct almost, because that was not intentional, it was kind of semi-intentional, is in a traditional world of script-based testing, you pretty much will see most of organizations have siloed testing. There's a manual testing team, and this manual testing team writes narratives, and they use some tools for writing these narratives. And then when they start automating, there's an automation team that replaces these narratives, in best case, in a test automation framework, with keywords and data. True, right? So it's not the same asset anymore. It's the same test case with the same intent, but it's two different physical assets. The one is still a narrative and has here some lines in plain English. The other one has exactly the same in a keyword form that does the same or is supposed to do the same step over here. Now, if anything breaks, and Raj, if you were the specialist here to run this, it's Friday afternoon, there's 1,000 test cases in the automated suite, and it breaks, okay? And he's managed, his KPIs are around, you've got to have this up and running at all times. And what happened is it's not just a technology change, there's a change to the business requirement. They inserted a mandatory field in a particular business process which stopped your test cases from progressing because the system rejects you. It says, look, you've got to provide some data for that mandatory field. Now what happens typically is Raj would go here and fix it. How often would you see these test experts coming over and saying, hang on, I've got to update this as well because it actually is a change in the business logic? Rarely ever, because it's not their task. These two are never ever in sync unless someone makes a conscious effort to do so, because there is no mechanism that automatically keeps them in sync. And that's the same problem that we had in the early days of computer-aided design, where organizations started to blueprint systems before they coded. Eva Jacobson, Grady Booth, Jim Rambeau, big names in the industry who invented graphical notations, a language that enhances human-to-human communication, in an early game of software development, with very much like a blueprint from an architect for a building, before the bricklayers come in and build the house. Right? They had the same problem because there was only one way. You had these blueprints, and then you pushed a button and you got some code skeleton out of this, and then you furnished this code skeleton with some code, and then you pushed a button and you got the build out of this. And then you tested the build, and the build was broken, and you had to fix the defect, and it would cost the developer about 2 minutes to fix it in the code, and about 2 hours to go back to the model, fix it in the model, and do it downstream again. That's why these whole case tools in the 80s had a very bad reputation, because they said, this is not workable. That's why then IBM, back then Rational Software, together moved into a technology which they called reverse engineering. They started reverse engineering the code back to a model. Because if you can keep them in sync with an automatic mechanism, you know what? You might actually retain the value of the model that you built in the first place. If not, your model goes out of the window because the executable is the one that provides the value in the long term. It's the software that runs. So in that sense, it's similar to that approach. Now, to sum it all up, thank you very much. The first generation record and replay, don't get me wrong, I'm not here to blame record and replay. I've used it myself, I'm a developer, I've 25 years of developing and being an architect, and only recently moved into a more management position. And I've used it. And there's very good use for this today still. If I was an IT administrator and I have a web server and I need to check that certain services are up and running every hour, every day, every unit of time, you know what? If the underlying infrastructure of my operating system is not going to change daily, that's a fantastic technology because you get it very cheap. You use it and it will run and it won't break that easily unless you change your operating system, and the cores will be different, and then it might break. So that's really, really good. But in a software development sense, where the only purpose for automation is to do regression testing, mostly. There's also automation for data provisioning and other stuff. But the original intention was to test that we haven't broken something that existed beforehand. You know what? The only driver to do this is change. And the change is likely to break any record and replay technology, okay? Because it's hardwired. That stuff absolutely solves the problem of the fragility, but it's a very costly undertaking. And it's usually not very scalable. And this is why you see in organizations, there's some exceptions. There's even an exception in here today. A very successful team of automation specialists, and I had the pleasure to meet them. But mostly it's confined to pockets of success. It's confined to some systems, but not holistically, easily across a heterogeneous system environment. Now, model-based testing in that sense, there's two mindsets as well that I want to kind of leave you with. One is in a script-based testing, the mindset is very much about automating test cases. Okay? In a model-based testing, I couldn't care less about your test cases. I'm automating systems. Okay? So my mindset is in automating the system, not the test case. What you run on that automated system, what test scenarios, that's entirely up to you. That's the first. Change that mindset. Change your mindset from automating test cases to automating systems. It will make your life much easier. Secondly, I strongly advise and advocate use object-oriented principles over descriptive programming. It will give you the benefits of encapsulation, separation of concerns, and reuse, and therefore a huge benefit in developing and maintaining the systems. And thirdly, code for the right reason. Model-based testing, I'm not trying to send you here snake oil in terms of there's no coding. It's a machine-to-machine communication. Of course there's coding. But there's coding for only one reason and for the right reason. You code to make two machines talk to each other. You don't code for automation frameworks anymore. You don't code to get robustness and separation of concerns between your test logic and your implementation. What you code for is, if you stumble across proprietary technology that your system, your automation technology cannot even recognize, they can't recognize this object, they can't recognize the behavior, they can't use its properties, that's where you need to start coding. This is almost like in a language, if we all speak English, and if I now add some words to the English language that you've never heard about, you know what? I would need to explain this, right? Or you would need to question me what I mean, right? And that's the right purpose of coding, because there you need to code. But all the other coding is, there's one more, maybe recovery scenarios, because nobody can predict the myriad of scenarios that you would have in your IT infrastructure. But otherwise, that majority of coding that is done in automation framework is obsolete. You don't need to do this. Okay, and with that, I want to leave you. That's pretty much the concept of what is the journey of model-based test automation. There's certain benefits that you get. Obviously, it gives you one word. It unites testing again. There's no separation between a manual test case and an automated test case. A test case is a test case. It's the objective of testing. You describe it in plain English. You choose to execute it manually, semi-automatically, fully automatically, it's your choice. Okay? Secondly, it will work across UI and non-UI, because it doesn't make a difference here either. It works across different technology if you do it right, the concept, if you implement it right. It will work on bespoke systems or packaged applications, and it will work in an agile environment or in a waterfall. Because in an agile environment, sometimes we have got some critique on model-based testing. I'm not talking now about a specific tool, really about the concept. Why would the concept of model-based testing not be as good as coding the automation framework alongside with the code that you develop? You know what? You will, when you code it, you will still need to code the connectors and driving tables and driving complex objects. Now, if you do this a bit more smarter and you build some generic connectors for these technologies, you don't need to restart every time in each and every project. You can reuse this. It's just a technology questions. It's just a question of, do you understand the syntax of that particular Java library or that particular .NET library or that version of Power Builder or HTML4 or Google Web Toolkit? That's all you do. It will give you this separation of concerns which will impact, which will minimize the impact of change. If change happens, you will have one point of maintenance, not 3 or 4 or 10 or 50 or 100. One point of maintenance. It's fast in the implementation, and there's enough case studies out there in model-based test automation, because you can speed up, you can have much more reuse, and you can speed up the implementation because you can reach out to non-technical staff existing. Okay? Not for coding the connectors, but for building the model and building the automated and maintaining the automated test scenarios. And it gives you the possible lowest maintenance point. I'm happy to be challenged. If anyone thinks we could do better, please. I have a purist mindset. I will never stop asking questions. I would be happy if someone challenged me and said, I have a better way to do this. Please tell me. I would love to learn about it and I will throw it overboard. And it's scalable because it's consistent user experience. It's like there's no difference if you automate a web service in a component testing stage or if you automate across multiple systems and technologies in an end-to-end user process. It's the same thing. It's the same learning experience, almost like driving a car. When you, for those of you who have a driver's license, right? If you had a petrol car at home and you go to Hertz tomorrow and they don't have a petrol car, they only have a diesel car, you can still drive it, isn't it? You don't need to know that a diesel engine works quite different from a petrol engine. It's not a concern of you. All you need to know is when you fill up the tank, here's diesel. Okay, but otherwise it drives the same way. So the learning curve is much lower because it's the same approach across technologies, across bespoke systems and packaged applications. And therefore you get the benefits of on-demand staffing. If pressure is really, really high, in the delivery you can actually embrace more people per system. That's it for me. I'm happy to open it up for questions and answers. Or because I said Allianz earlier, they have actually automated 95% of all their test cases. Over to you. Can you repeat the question?
Okay, I would like to say the model-based approach you just said about.
Yeah.
Is it a middleware kind of thing which will be plugged into different systems? So, for instance, I have someone who's having very complex systems, capturing data from mainframe or putting that data into different multiple databases and multiple applications or reporting applications are fetching information. So, in order to test those systems, I mean, I'm plugging in this middleware. The corresponding test engineers, I mean those who are writing the test cases, he's simply writing the English-like languages in order to test the system. Is it the middleware kind of thing which we should think about? I mean, it can be plugged in with multiple systems.
I see where you're coming from. It might look like a middleware, right? Almost like a middle layer. Like you had an enterprise service bus, this kind of an orchestrator that it receives some messages, it delegates this somewhere else. So the analogy is quite good. In that sense, what it really is, it is you separate the concern of how systems talk to each other, what language they use, so that's the technology connector. How a system is built, what its architecture is, how it's broken down into functional blocks, and how this functional blocks can be used as siloed tests, a lot of functions, but also as tests across these functions. And you want to achieve, in order to, I think the biggest problem with script-based testing, besides let's set aside that you had a great team who develops a good framework. One of the problems is often then also the maintenance of these frameworks with the systems when the system change. So what you want to achieve is you want to achieve a single point of maintenance for a particular concern. If data change, I only want to change this in one spot, not across multiple layers. If the automation, if the underlying system technology changes, I want to change this in one spot. If the flow changes of the system, I want to change it in one spot. I don't want to have these multiple touch points where I need to think about, okay, I need to actually change it here, and I need to change it there, and I need to change it there to fix it, right? So you have a very clear layered architecture, if you like. In that sense, it's almost like the model view control principle of object orientation. So model view control principle is similar in that sense. You separate the rendering of information, on a screen, how you display it, from the orchestration, how information and systems are orchestrated to do something together, from the underlying data model that are in the system. So in that sense, it's just a multi-layered architecture that solves exactly the same problem. You're welcome. I did want to add something very briefly, if I may. Can you hold on with the question for 1 minute? I also wanted to make a point. Don't get confused with model-based testing. There's an approach out there. It's called MBT as well. And model-based testing has been around as long as model-based test automation, since early 2000s, 2002. It's got a French company who started it. And model-based testing, MBT, is an attempt to use graphical notations for deriving testing needs. So you use the same graphical notations, such as a unified modeling language, where you have sequence diagrams, state diagrams, activity diagrams, use case diagrams, that define the system, that define the functions of the system. And then obviously you can use these sequence diagrams and activity and workflow diagrams and state diagrams to derive your test needs. Because it's quite logic. It's embedded already in that logic, right? And I'm a big fan of it. I think it's great if you speak UML. Okay? The problem is there's too many people out there who really speak UML well. There's some who can read it, but not many who do really good models. Now, if you happen to be in an environment where your software engineering team uses graphical notations for blueprinting systems and building models before they're coded, and you get hold of these models and they're up to date, and you speak that language, you speak UML as an example, by all means use this. It's fantastic. It's really, really good. You can get testing leads very quickly. Where it failed is on the automation side. We looked into this as well. The reason it fails on the automation side, the graphical models are a means for human-to-human communication, not for a machine-to-human communication. It's an abstraction of the code of the executable. It's not the code itself, unless you use code visualization techniques, yet another technique. Now, in that sense, graphical notations don't have enough detail for a machine-to-machine communication, of which test automation is an example. It's two machines that talk to each other. So in that sense, that's why we took a different approach for the automation side. We said, look, we need to derive the model for the automation from the executable, not from its abstraction. Because the abstraction wouldn't give me sufficient detail that my machine can talk to the other machine. Okay? Unless you were to use an actionable graphical notation, but then why do you code? Then you don't need Java and .NET to any coding language anymore, because it is the code. You enrich your graphical notations with an action language so that your graphical model becomes an executable. There's attempts out there, again, for 10 years, they've never really taken off. It's a very complex process. Very, very confined spaces. It works, but not across the industry. Otherwise, we would do it already. So, sorry, there was a question.
So, as I understand, the model-based is nothing but we create some classes, classes but a code, which will interact with the component or the system, which can give a flexibility to the test to talk with the system to get information and test it. So, is that same, right? So, is it business model testing or business component testing, business process testing? Everything is same. Right? So nowadays in real time, I don't think nobody is using this record replay or script-based testing, and everybody has some level of automation framework implemented, functional, keyword-driven, kind of that. So in my experience, what I identified is that when we create models or functions or classes, purely I know it is the OOPS principles we have to follow, but how effectively we can implement that, it's what matters, right? So in my experience, I have created a business component to test a business functionality, and when I'm using that, calling that from multiple tests, later of some time I realized that this model or this component should have been split into different things, as individually it cannot give any. In some places, directly I cannot use the model because it has some integration together. So it has to again split into minute level. So I know it's purely on OOPS principles that we have to follow. At what level we have to minimize to bring down the model to make more reusable or more robust. But is there any proper guidelines or definitions to consider while defining a model? To say, this is the kind of models you have to create to give a more reusable kind of that. So overall, if you say, we can say that business model testing or model-based testing, it gives more reusability. But in real time, when you really implement it, how individual minute level models that you have to create is what gives a more effectiveness. So what is the main principle or guidelines that we can follow to make that more accurate, actually?
It's a very good question. Two things. I used the analogy of classes. We are not producing classes. It's not code. Okay, the model is not code. The model uses actually in the implementations that we've seen, they use just a structural format such as XML. Like you would have, XML to define web services in a WSDL file, or XSDs, that's schemas, right? There's no code. It's not coded. It's not classes. It's not really a Java class or .NET class or a VB class, if it's VB plus. It is just information, enough information to talk to the actual system's interface. Okay. The analogy is the same of a class because it in itself doesn't do anything. It just sits there and says, I can do everything that the system can do through this interface. But I don't know what to do. I'm not the one who determines what makes sense. What makes sense is defined in your test logic. So the analogy is right, the implementation is not. I'm not suggesting you should write code to do this. What I'm saying is, if you write smart connectors one layer down to talk to the technology, you can non-programmatically derive these models without any code. So in that sense, it eliminates the coding for the framework, for the model. These models are not coded. They are scanned from the interface, and all they use a technology connector that knows enough about the underlying technology that you can say, okay, if this is a button in Java, then if it's a table in HTML, I treat it like a table in HTML. If it's, let me give you an example. If it's, and you will find this, if you happen to automate HTML applications, okay, so web-based applications, and you have here a browser, could be Chrome or IE. I chose blue, so it suggests almost like it's IE, isn't it? But could be Firefox, doesn't matter really. And let's say in this web page you have here a table, right? And this table has a first name and a surname and a date of birth and some other stuff. And then it's got obviously records for the individual people or clients. If that system was developed in standard HTML, what you would see is underneath the implementation, what you don't see in the browser is the user, the person who views the code or has coded it. What they would see is there's a table tag, it's called table. There's a table tag, and within this table, since it's standard HTML4 or 5, there would be a table row tag, and within the table row tag, you would have data cells, TDs, and so it goes. And then there's somewhere, obviously, there's an end tag of the table. Okay? So what the user sees is this. What the automation technology sees is this. So it looks for a table. And that's plain HTML, HTML4 or 5, as an example. Standard implementation. If you happen to use a Google Web toolkit framework to build your applications with a bit of more modern look and feel. And they've done some crazy stuff that I don't understand why they've done it, but someone has smoked something, I guess. When you look at this same browser that displays a table, but it happened to be implemented in Google Web Toolkit, the user still sees a table. Here's the user, and all he sees is a table. The automation technology underneath will see a diff structure. And this diff structure are just generic HTML elements where each and every diff does not tell you, is it the table, is it the row, is it the column, which column is it, what does it do? All you know is there's a diff structure. Now imagine you had a table that has 10 columns and 10 rows. What you would see is there's one diff for the table, there's one diff for each and every row, makes it 11, and there's 10 diffs for each and every cell in each and every row is another 100. So what you would really see in the automation technology, there's 111 diffs, which is very different from a straight table. Okay? In that sense, if you were to automate this now, using a standard technology, and let's say you click here on, you want to know the first name where it says Tim. And Tim happens to be here, uniquely identified by first name, happens to be in row 3, column 1. Okay? So we have the diff for the table, the first diff. We have a diff for the first row, which is 2. We have 10 diffs for each and every cell in the first row, makes 12. We have row 2 makes 13. We have 10 for each and every diff in row 2 makes 23. We have row 3 makes 24. We have the first cell in row 3. Tim happens to be diff, what did I say, 24. Okay? Now imagine there's a smart boy who says, hang on, firstly, the content might change. Tim might not be in row 3 anymore because Praveen is in row 3, Tim is in row 4 now. And secondly, these tables are dynamic. You can actually change the columns and their order, so it might not be actually in the first name in the first column, it might be in the second column. What are you going to find with this stuff? Nothing. It's already gone, it's out in the window. So in that sense, there is coding for the right purpose. What you can tell if you use the concepts of model-based test automation, what you tell your technology adapter is whenever it comes across a diff structure that looks like a tree and has certain patterns, meaning it's got the same amount of diffs within the lowest layer, layer 3, then most likely it's going to be a Google Web Toolkit table. So what you tell your technology adapter, treat this like a Google Web Toolkit table, and what you are connectable to it will convert this into a table. It will load the content into a table. So when the user uses it, from an automation perspective, he only says, give me the first name, wherever the column is, give me the column of the first name, and search for Tim. And therefore it goes back to the human eye. Your verification will work very much like the human eye, and it's independent of layout change or content change. It won't break. Okay? That's a good example of coding, but that coding is on the connector level. It's like in the engine. If you tune your engine, your diesel engine, you've got to know what the inner workings is. For us who drive the car, for us who use a technology that employs these techniques, we would always only see a table. We don't care. Even the test automation specialist, you will always see a table. It doesn't matter how it's implemented underneath. And when you do this once, it doesn't matter how often that Google Web Toolkit table is exploited. If it's on one screen, on 2 screens, twice on the same screen, on 100 screens, on 50 applications, I couldn't care less. It's just how Google Web Toolkit treats tables. Does that respond to your question? So in that sense, the separation of concern is very clear as to what happens where and for what reason. It's you want to get to this point of a single point of maintenance. If I have to maintain technology, syntax, I only do it on the connector level. If I have to maintain the architecture of the system that I'm automating, the model that I built to abstract the system, it's only in one layer. If I want to maintain the flow, it's only in one layer. If I want to maintain the data, it's only in one layer. Very clear separation of concerns and implementation. Yeah. I've been warned a number of times. You're very patient with us. Can we take this offline? I'm more than happy to stay on for those who have questions and are still interested in this discussion. But for the rest of you, please feel free. We are aware it's got late, and you have family and friends, and probably decide to have a drink somewhere. So I'm happy to take that question offline. Okay.
Okay, thanks Dominik and Leah, and thank all of you for attending. It's the whole reason we're here is for you to build a community within Singapore, Singapore testing community. So, just like to say thank you very much again for attending. We will post details about the next event. As Dominik said, by all means stay on and chat a bit more about the concepts he's discussing. But I'd like to wish you all a happy Christmas if you celebrate Christmas, or and have a good holidays, and we'll see you back here in February. Thank you very much. Oh, one thing, if you have feedback, if you could just leave the feedback forms on the chairs, we'll come around and pick them up. Thanks a lot.
Do you want to say anyone wants to use it practically?